A cyclist comes to the top of a hill, 165 meters long traveling. A cyclist comes to the top of a hill, 165 meters long, traveling at 5 meters per second. Something is grammatically wrong with this question, Khair. And freewheels down it with an acceleration of 0.8 meters per second. Okay. Write an expression for his speed and the distance he has traveled after t seconds. Hence, find how long he takes to reach the bottom of the hill and how fast he is then traveling. Okay, so he's riding downhill. What do we know? That at the top, initially, he was traveling uphill, and you're told the speed at the top. So this one would be 5 meters per second. And then he's going down the hill. So now this becomes your initial speed for the downwards journey. So we disregard this part. So U is 5 and acceleration here is 0.8 meters per second square. Write an expression for his speed and distance he has traveled after t seconds. Okay. Also, we know that the total distance from here to here, the entire distance is 165 meters. Okay, so we have to write an expression in terms of t seconds for his speed and the distance. Let's talk about speed first. So at a particular point, let's say over here, you have to find what is his speed. So that means you have to find v. So I'm going to write down the equations of motion that we know. It's one of them is v is equals to u plus at. We could use this, by the way. Okay, and then there's v square equals u square plus 2as. We can't use this because we don't have the distance traveled at time t. We have the total distance traveled from top to the bottom of the hill. That's 165. But we don't have distance at a particular point. We're finding speed at any particular point. Okay, so another formula that we know is S is equals to ut plus half at square, or S is equals to vt minus half at square. And another one is S is equals to half u plus v times t. So we have to find the expression for v in terms of u and a and t. So it's going to be this equation. V is equals to 5 plus 0.8 t. This gives the expression for v in terms of t. Okay. And the distance as well. He travels in t seconds. So now we need to find S given u and a, and t will stay t. So we're going to use this one. Because it has u in it, 5. Then it has t in it. You have to give your answer in terms of t plus half times a we know and t square. So this becomes S is equals to 5t plus 0.8 square divided by 2. 0.32 t square. Sorry, why did I square 0.8? I wasn't supposed to do that. It's going to be 0.4 t square. The square is on t, not a. So square is over here. Okay, so this is the second equation for S in terms of t. Hence, find how long he takes to reach the bottom of the hill and how fast he is traveling there. Okay. So when he reaches the bottom of the hill, that is this point, you know the distance covered. So 165 meters. So now in the second equation, replace S with 165 and find the time. Because it says, hence find how long he takes to reach the bottom of the hill. So you need T. You have S and we get a quadratic equation in terms of t. 0.4 t square plus 5t plus 165 equals 0. Sorry, minus 165 equals to 0. Apply quadratic formula here. So t equals minus b plus minus b square minus 4ac upon 2a and this would give 15 seconds or minus 27.5 seconds, which we will ignore. So the time is 15 seconds. And also you have to find the final speed, hence find how long he takes to reach the bottom of the hill and how fast is he then traveling. So you have to find V at the very end of the slope. So we need V here as well. So now we have so many perimeters. We have U, which is 5. U is 5. A is 0.8. S is 165. And time we know is 15 seconds from top to the bottom. And we need V. So there are a lot of formulas that can be used because now you have 4 parameters. So you have multiple options. I'm going to use the very first option. V is equals to U plus AT. So 5 plus 0.8 times 15. Answer is 17 meters per second. 5 plus 0.8 into 15 is 70 meters per second. Any questions here?
No, ma'am.
Okay, next question was, what was the next homework question? A car traveling at 10 meters per second. Aisha?
जी
यही था? Okay. Okay. A car traveling at 10 meters per second is 25 meters from a pedestrian crossing when the traffic light changes from green to amber. Okay, so there's a car. Let's draw a very accurate looking car. Okay, traveling at 10 meters per second. So its U is 10. Is 25 meters away when the traffic light changes from green to amber. Okay, so it's 25 meters away from some place, from a pedestrian crossing. There's a pedestrian crossing over here. Okay. When the light changes from green to amber, amber is red, I think. So there's a traffic signal over here, and it changes from green to amber, probably red, yeah, maybe orange, I don't know. Okay. So within, so yeah, there's all we're told is that the distance between car and the pedestrian crossing is 25 meters and the initial speed of the car is 10. Okay, let's read the rest of it. The light remains at amber for 2 seconds before it changes to red. Oh, okay, then it changes to red. Okay. So within 2 seconds, the light will switch from orange to red. The driver has two choices: to accelerate so as to reach the crossing before the light changes to red. So either he just presses the accelerator and quickly crosses this 25-meter distance within those 2 seconds. Either that's his option. Or to try to stop at the light, or he must hit the brake and make sure that he stops within these 25 meters. Okay. Okay. What is the least acceleration which would be necessary in the first case? So the first case is that he wants to cross this distance of 25 meters within those 2 seconds, so that he crosses this spot and he does not have to he does not have to stop. Okay. So in that case, what information do we have for case 1? So he wants to cross the entire distance, right? Within those 2 seconds, because he needs to cross it. So for that, U is going to be 10, that we already know, that's his initial speed. He has to cross the entire 25 meters distance. So S is equals to 25 meters. Also, he just has 2 seconds to do this, because otherwise the light will become red. So time is 2 seconds. Okay. So the question is, find what is his least acceleration. So you have to find the acceleration. Okay, so that's going to be what, or what equation of, which equation of motion should we use? That has U, S, and T in it. There was V is equals to U plus AT. So not this one, because we don't have V.
MS is equals to VT plus half AT square.
UT plus half AT square.
UT. So UT.
VT minus half AT square is the equation, or UT plus half AT square. Plus in this question, we have U, not V. So we have to use this one, the one with U in it. So yeah, let's go ahead and use that. S equals UT plus half AT square. So 25 equals 10 times 2 plus half A 2 square. Can you find A from here? So 25 equals 20 plus 4 by 2, 2A. So is it 2.5 meters per second square? Yeah, that is the correct answer. So A is 2.5 centimeters square for the first case. Okay. Now you have to find the deceleration for the second case. Now, what was the second case? Okay. So for case 2, again, we have to find the deceleration, which is negative acceleration. So we basically have to find acceleration. And what else do we know about the second case? In the second case, the driver has to stop. He wants to hit the brake and stop. So in that case, U is still 10 because that's his initial speed. But let's say he stops somewhere over here. He just has to stop. He has to stop. Okay, so if he has to stop, we know that V is going to be 0. So we also know V for the second case. Okay, so if the question says find the least deceleration. Least deceleration means that he is allowed to take as much distance as possible to slow down. And what's the maximum distance he can use before stopping down? That's the 25 meters distance before the pedestrian crossing. So if he's allowed to slow down relatively leisurely, then he's allowed to take the entire 25 meters distance. So the least deceleration would be when the distance, all of the distance is taken. If he wants to stop abruptly, like right here, then the deceleration has to be a lot more higher. And maybe would be minus 20, for example. So he will have to decelerate really, really, really fast. But if you want to find the least deceleration, that means you can stop right over here. Take as much distance as possible to slow down. So that's why we're going to take S is equals to 25. Okay. So now again, give me an equation which uses U, V, S, and A. Which equation of motion uses A, U, V, S? Okay, I'm going to write the equations of motions. V is equals to U plus.
V is equals to V square is equals to U square plus 2x.
Yes. V square equals U square plus 2AS. Okay. So it's going to be 0 square equals 10 square plus 2 times A times 25. So minus 100 equals 50A. So A equals minus 20 meters per second square. Okay. So these were the two homework questions. Now we move on to the next question. Okay. A freight train, 4 kilometer long, takes 20 seconds to pass a signal. So there's a signal. And there's a train that is 1/4 kilometer. That's a huge train. Okay. And it takes 20 seconds to pass the signal. That means it takes 20 seconds for it to completely cross it, to completely cover the distance of 1/4 kilometers. Okay, the train is decelerating at a constant rate. And by the time the rail track has passed the signal, it is moving 10 kilometers per hour slower than it was when the front of the train passed the signal. Okay. So that means initially, if the speed was X, let's say U was X initially. So later, it is 10 kilometer per hour slower. So it's X minus 10. Find the deceleration in kilometers per hour. So we have to find A. In kilometers per hour unit. And the speed at which the train is moving when the rear end has just passed the signal. Okay, so we need the acceleration and the actual value of V. So that means we'll need to find X first and then do X minus 10. Okay, so all we know is that the distance is 1/4 kilometer. So S is 1/4 kilometer because the train covers a distance of its own length when it's passing through the signal, because first its front is at the signal and after 20 seconds its back is at the signal. So that means that the distance traveled is 1/4 kilometers. 1/4 kilometers. Okay, and it takes 20 seconds for the train to cover this distance. U is x, v is x minus 10, and we need to find the value of a and then the value of x. So how do we find a from this information? We know u, we know v, we know s, and we know t. And u and v are in terms of x, by the way. Any equation that uses these 4 parameters?
V is equals to u plus 8.
But you have to find x. Find x first. That would give you u and v, and then you can find it. Yeah, find x first. So use u, v, s, and t. What equation do we use? Which equation do we use? और अजर के अलावा भी कोई बता सकता है? Which equation of motion has u, v, s, and t in it? I think this one. S equals half
U, V, and S.
u plus v times t. This one. So S is 1/4 equals half, u is x, v is x minus 10, and t is 20 seconds. Okay, so this would be 2/4 will be half equals 20 times 2x minus 10. Okay, solve this and give me the value of it. Okay, hold on. I think there's a unit conflict in the question because time is in seconds and
Kilometer per hour में deceleration होगी.
One second. 10 kilometer per hour. Yeah, so this is in hours per hour. So that means the time has to be in hours as well. So 20 seconds would be 20 divided by 60 into 60. So this would be 20 seconds in hours divided with 60 twice. So that would give 0, 0 gets cancelled, 1 and 6 gets cancelled. So that is going to be 1/180. So I'll replace the 20 with 1/180. So then when you cross multiply, you get 90 equals 2x minus 10. And then x equals 50. Okay. Okay, so we know what x is. That means we know what u is and we know what v is. So this is now 50 and this is now 40 kilometer per hour. Okay. Also, we have to find the acceleration now. So now we have actually 4 parameters. Sorry, बार-बार लगता है कोई knock कर रहा है. नहीं कर रहा कोई knock. Okay, so acceleration find करनी है. So now which equation of motion can we use? And I would prefer if someone else other than Azhar answers this. Let me write the equations down for you, although you need to memorize them. V is equals to U plus 80.
इस समय फॉर्मूला शीट में गिवन होंगी.
साल में एक सेकंड मैं जरा कंफर्म करती हूँ. And then this S equals half U plus VT. Okay, figure out which ones can be used to find acceleration. When we have U and V and S in T, there would be more than one possibility. Let me open the formula sheet in the meantime.
मिस एक तो यही वाली होगी जो हमने पहले यूज की है. S is equals to 1/2 U plus VT.
अच्छा, एक सेकंड में देखती हूँ. Quickly check the mechanics part. Yeah, they're all given. 1, 2, 3, 4. Actually, 4 of them are given.
मिस
Eight.
कौन सी नहीं गिवन?
S is equals to VT minus half AT square. That's really strange. Nahi given. VT minus half AT square is not given. Why would they do that? Anyway, it's not. 4 of them are mentioned. And these are the only formulas mentioned in the mechanics part. No other formula is mentioned. Let me just cut paste it for you guys as well. So mechanics part just has this. That's it. Just 4 out of the 5 equations of motion. Then there's further mechanics, which of course we don't study. So S equals VT minus half AT square is missing. Okay, back to the question. What can we use here? We have U, we have V, we have S, and we have T. We have to find A. So I'm going to use this. V is equals to U plus AT. V is 40. U is 50. Time is 20. So this would be minus 10 by 20. So minus half. Meters per second square. Let me check the answer. नहीं है ये आंसर. 50 x is equals to 50 ठीक था, v equals to 40 ठीक था. Acceleration is not. Oh, we have to give it in kilometers. So I probably wasn't careful about the units. Let me just confirm. Do we have everything in kilometers per hour? No, again, the 20 was in seconds. It shouldn't be. It should be 1 over 180 instead. So let's fix that. 1 by 180. Can you tell me what do we get for A now? Because we need to give the answer in kilometer per hour, and the distances are already in kilometer. I mean, the speeds are already in kilometer per hour, kilometer per hour. So the time should have been in hours as well. So it is now minus 10 into 180. equals A. Now it's correct. Minus 1800 kilometer per hour square. Okay, next question would be cheetah and impala question. Yeah. A cheetah is pursuing an impala. Okay, so there's a cheetah C and there's an impala. So this cheetah is pursuing an impala. Impala probably hiran type कुछ होता है. But I don't know आप अगर बच्चों को पता है कि हिरन क्या होता है. But मेरे ख्याल में वही होता है. Okay. So a
जी में
cheetah
सिरे नहीं होता.
हिरन ही होता है ना. ठीक. Okay. A cheetah is pursuing an impala. The impala is running in a straight line at a constant speed of 16 meters per second. So, इसकी speed constant है impala की. So V कह लें या U कह लें, constant ही है तो चलो U कह देते हैं. Although it does not make any difference. So 16 हो गई meters per second और ये है impala की constant speed. Okay, so the impala speed is constant, it's 16 meters per second. The cheetah is 10 meters behind the impala. So initially, when this recording started, the distance here is 10 meters. Okay. The cheetah is 10 meters behind the impala running at 20 meters per second. So this, but tiring. So he's initially running at 20 meters per second. So the U for the cheetah is 20, but his speed will change because it says that he's tiring down. So his speed is not, its speed is not constant. So that it is decelerating at 1 meters per second square. So cheetah has a deceleration of 1 meters per second square. That means its acceleration is -1 meters per second square. Find an expression for the gap between the cheetah and the impala t seconds later. Will the impala get away? Okay, so you have to find an expression for the gap. Now let's form the gap. The initial gap is 10, but eventually when they're moving forward, this gap keeps changing. So let me make another chart. Okay, so this is cheetah initially, but then it moved some distance, calling this distance moved by cheetah. Okay, so the cheetah was here and then it's here at some time. Okay, and then the impala started from here and let's say it also moved some distance. So this is going to be the distance covered by the impala. Okay, so the cheetah right now is over here. The impala right now is over here. So the gap is going to be this distance. This is the gap, the current gap between cheetah and impala. The initial gap between the cheetah and the impala would be represented here. The initial starting point of the cheetah, the starting point of the impala, this gap was 10 meters. Right? Okay. Now we need to form an equation that has SC, the distance covered by the cheetah at particular time, SI, the distance covered by impala at particular time, the 10 meters initial gap, and this gap whose expression we have to find now. Okay. This meeting is ending in a minute. I'm ending it now and sending you a new link. Okay. Now we have to form an equation that has distance covered by cheetah, 10 meters, distance covered by impala, and the gap in it. So Look at the lines that I've drawn. Notice that the sum of this line and this line, if you add these two distances, they're the same as the sum of this distance and this distance. So which means that the distance covered by the cheetah in time t plus the gap is equals to 10, that was the initial gap, plus the distance covered by impala. Okay, there's also a general formula for this as well, which is new gap equals to initial gap plus distance of the animal that's ahead. So that's the impala minus distance of the animal that's behind. So that's cheetah. So if you can remember this formula, very good. Otherwise, you'll have to make this diagram and figure out what's the relationship between SC10, SI, and gap. Otherwise, remember this formula that gap, the gap at t seconds equals to the initial gap, which is 10, plus distance covered by the animal that's ahead, which is impala in this case, minus distance covered by the animal that's behind, SC. Okay, so 10 plus what is the distance covered by the impala in t seconds? For impala, we know that the speed is constant. And when the speed is constant, you don't use all the equations of motion, you just use S equals Vt. Distance is equals to speed into time. So that's going to be S equals 16t. So the distance covered by the impala is 16 times t. Minus distance covered by cheetah. So for cheetah, we know that A is -1, initial speed is 20, time is just t because we're giving our answer in terms of t, and we have to find the distance, S. So we can use ut plus half at square. So distance covered by cheetah would be ut plus half at square. So it's going to be 20t plus half times -1 times t square. So 20t minus half t square. This is the distance covered by impala. So minus bracket 20t minus half t square. Okay. Equals the gap. So it's 10 plus 16t minus 20t plus half t square. Collect the like terms. So half t square plus 4t plus 10. This is the expression for the gap between the impala and the cheetah at time t. Sorry, it's supposed to be minus 40, not plus 40. Okay. So this was what was required in the first part of the question. Find the expression for the gap between the cheetah and impala at time t. That's done. The last part of the question says, will the impala get away? So will the impala get away or will it be caught by the cheetah? How would you establish that? If the gap becomes 0, if you can find a time at which this gap becomes 0, that means that the cheetah catches up catches the impala, because there is some time, like 20 seconds, 30 seconds later, when the gap becomes 0. Then the cheetah catches the impala. But if the gap never becomes 0, there is no value of t for which the gap becomes 0. That means that the impala gets away and the gap is never 0. So let's equate it to 0 and see if we can solve this quadratic equation or not. Cheetah can catch impala if gap can be equated to 0. So let's try that. 0 is equals to half t square minus 4t plus 10. I'm going to write it as 0.5 t square minus 4t plus 10. Apply the quadratic formula, minus b plus minus b square minus 4ac upon 2a. Okay, this is, when you solve it, you get a negative value here, because that's 16 minus 20. So you won't be able to solve it and you'll get math error. So that means no solution, since the discriminant is negative. No solution. Which means that there's no value of t for which the gap becomes 0. So the impala gets away. The gap can never be 0 for any value of t. So impala gets away. This was a difficult question from the book, but there's a question like this in the past papers as well. So that's why I wanted to do this.